Hello, dear participants of our event. We thank you for our coming here for our event. We appreciate everyone for their attention and presence. I would like to introduce our speaker to you, Professor Sérgio António Neves Lousada, PhD. RCV Sérgio António Neves Lousada holds an international PhD in civil engineering hydraulics. He teaches at the University of Madeira, specializing in hydraulics, environment, and water resource and construction. Professor, you can start. We can begin. Thank you.
Good morning to everyone. Thanks for your introduction, Professor Victor Cremones. Also to say thanks to Professor Anderson Ketepen and Darian Ketepen for the invitation for this Congress. And also special thank you for all the audience. My name is Sérgio Lousada. I work at the University of Madeira in Portugal. I will do the presentation of my work with the team Hydraulic Planning in Insular Urban Territories, the case of Madeira Island, Ribeira Brava. This work have 5 parts: an introduction, materials and methods, the results, discussion, and some conclusions. So, global warming, with its increasing variability, leads to an increased risk of both floods and droughts. So, how does climate change affect flood risks? Warmer and wetter atmosphere, more energy for storms, coastal flooding, and more intense downpours. So, flood reasons: heavy rainfall caused by natural weather events, insufficient forests, incorrect agricultural practices, inadequate design of drainage channels and structures, inadequate maintenance of drainage facilities, clogging and rural buried by flood waters, and settle down of flood plains. So, the source of water, in addition to determining the amount of water falling on the surface in terms of vegetation characteristics, influences the amount of water on the floor, underground infiltration of ground in terms of soil properties, plant and underground water linking from the amount of residual flow to the understanding of the causes of floods and geomorphology relationship is extremely important. There are also incorrect land uses and engineering institutes on stream beds that assume important roles in the formation of floods. At these erroneous and often uncontrolled urban sprawl expands to rural areas. There is obviously the need to put structural and non-structural measures into action to prevent or at least mitigate flood impacts. Taking all of these into consideration, this study aims to perform a hydrological analysis of the municipality of Ribeira Brava, estimating its peak flow rate for a return period of around years and the establishing comparison with its watershed's river mount drainage capacity. So, the area of study is located in the southern slope of Madeira, is one of the 11 municipalities of the Madeira archipelago. Ribeira Brava Basin suffered with major flooding events like the ones that took place in 2010 and 2013, resulting in both civil and assets catastrophic losses. Ribeira Brava also suffers from anthropogenic pressure, much like any other urban municipality, particularly felt by a considerable soil sailing index as a result of an urban sprawl over a semi-rural area. Furthermore, its main watershed river mount is covered in abundant vegetation and a vast tract of sediments that considerably reduce the drainage capacity of this water channel. The state of conservation of the stream is virtually the same throughout in its length within the urban perimeter, which can be clearly confirmed in situ. So, the schematic of methodology. The case study follow a methodology with 6 major stages, with the first being a deep literature review with the purpose of getting the much needed hydrological and morphometric analysis of Ribeira Brava's watershed. To present a valid contribution for the study of four-point water courses, different methodologies were also taken into consideration, suggested by prestigious authors, thus ensuring the reliability of this study outcome. The following steps are further explained above. So, we can start with a literature review, watershed morphometric analysis, hydrological analysis, analysis of the drainage capacity of the river mount, the tension basin sizing, and the definition of the robustness coefficient. So, intermaterials and methods also, like I have said in the last slide, the morphometric characterization of the watershed, we need to define some key parameters used to make the characterization of the watershed. The precipitation analysis, the hydrological study is performed based on a probabilistic analysis of extreme height, intensity, and short duration events that took place in Ribeira Brava's watershed throughout story. This data is obtained using National Weather Resource Information System. Okay. Next step is the drainage capacity of the river mount and peak flow rate. So for that, we need to define the drainage capacity of the river mount is calculated using the Manning-Strickle equation. The detention basin sizes, we can use two different methodologies, the Dutch method or the simplified triangular hydrogram. Also, another possibility is the modification of the robustness coefficient. Another structural measure that was taken into consideration was the modification of the robustness coefficient of the walls and stream bed of the main water course, as this would avoid friction between the water and the channel, therefore increasing its drainage capacity. So in this slide, in the first part, the table, we can obtain with the software ArcGIS some values of some parameters. Also, we need to prepare and work with the data obtained by the ArcGIS software into Microsoft Excel sheets and develop some formulas and obtain these results that we present in this slide. And with these ones, we can achieve if the watershed of the basin is four-point characteristics. Also, we can see in the figure number 3, the isometric map, that the Ribeira Brava watersheds borders are considerably higher than the central area, indicating a steep slope and subsequently a very fast supply of the main watercourse that increase the volume of water flowing out the stream that will end in this river mount. Also, in the figure number 4, the structural classification, we can show a higher number of streams, which also suggests that it was a higher drainage capacity. There are many low and medium order tributary streams that supply the main watercourse. So in this slide, we have 4 tables, and the first one is all the treatment made with data obtained by the National Information System of Water Resources using the Gumbel distribution probabilistic process. It's possible to obtain the value of precipitation. Okay, with this value we can obtain the values for the peak flow rate present in this table with 4 different methodologies: Fortier, Rational, Giandotti, and Mocus. And the most important is that this peak flow rate is estimated for a written period of around years. Afterwards, the table number 4, the detention passing sizing, is determined by two methods, Dutch method and simplified triangular method. The most important is defined that the width and the height is all times the same during all the length of the main water course, because we are working inside the municipality. We don't want to reduce the misuse environmental impacts on an urban area, so we define two fixed values, width and height, and we have only the possibility to change the values of the length of the main, in this case, of the detention basing size. Different methodologies are applied, so also at the end we have make another modification of the ruggedness coefficient, table number 5. The changing out of the ruggedness coefficient of the stream bed and walls is one alternative for flood mitigation structural measure. So, with this study, main goals is to check if this action to mitigate the floods is with the incorporation of the detention basin is useful, is valid, is possible to do in this municipality. We can achieve with different fill rates for different methodologies that if it's possible or not to make the application of the detention basing. Also, we can check, okay, it's possible, but also we confirmed with this study that our study also corroborate the regional directory for territorial management and environment prediction. Also, the two different methods, the Dutch methods give us an abnormal oversize of the detention basins length compared with the other one. So probably the simplified triangular hydrogram is better for this location for make the implementation into main water course. All these studies aimed to cause the least possible impact over the considered water course and its surroundings. The change of the stream bed and all ruggedness coefficient, it was decided to remain with the abundant vegetation and sediments along the water course, but improving its conservation status by performing a correct maintenance at this old outcome in a cheaper process with less wasting of time and resources. At the end, for some conclusions, this study revealed how full-poned Ribeira Bravas watershed is in the event of extreme rainfall occurrence. It was already predicted by Rota on flood risk report. The study leaves a clean open door to others that may complement its contents and methodology by optimizing its techniques. On the other one, mechanical abrasion of the streams, holes, and the amount of time that often takes to local public authorities to perform any type of maintenance have been two strong reasons for how degraded the main water course tributaries are, and subsequently by the lower water quality discharge, and therefore also need to be studied and improved. So the insufficient drainage capacity of the riverment as verified through 3 of 4 methodologies used in this study, namely Rational, Giandotti, and Mokos. The changing the watershed stream bread and old ruggedness coefficient may seem a relatively simple and unworthy measure to consider. It's solely purpose to mitigate the flood's impact, fulfilling its main goal by preserving infrastructures and people's assets. Furthermore, the urban growth relation projected for the municipality of Ribeira Brava, and though it may impact soil, waterproofing, and ultimate surface runoff, should be a top concern and study complementing this work's outcome. So I end my presentation. Probably I'm very quickly, but I'm able to talk about this subject, and if some of the participants have some questions to do, I will try to do my better and answer to him. Professor Victor Camones. So thank you for your time, for watch my presentation. Thank you.